Hey, before we get started today, I actually have a special guest who jumped into my lap a moment ago. No, this is not Stat the cat. This is Flame. Flame is our 17-year-old kitten, and she is the inspiration for Stat the cat. And sometimes she does come sit in my lap while I'm teaching, don't you, pretty girl? Who knows how long she'll stay, but let's go ahead and get going. I think Stat will probably show up sometime today too. Okay, she jumped away, so she's not here. What are we looking at today? We're going to look at another one trial example. I'm going to also look at the problem I assigned from last time. And today we're going to get into how do we do multiple trials. We're not going to do the statistical analysis of multiple trials yet, just the multiple trials. And we're going to go through the master list of problems so you know what problems you have to choose from and kind of know what's going on with them. So the first... quick review, by the way, just I wanted to hit this site. It wasn't clear, I think, the other PowerPoint slides. How do we generate different kinds of random variables? And there's a generating random values Excel file on Schoology that you can download. Okay, the trivial training example. This wasn't out as early as I'd hoped it would be, but this is out on Schoology as a problem that you should work on. And we saw this. This is a Chapter 2 problem. We did it with fixed cost and fixed revenue, or fixed units. Fixed cost, fixed revenue, fixed units sold, and looked at different profitability. So we had that input information, and we used data tables to create outputs. Well, as described here in your directions, and we're making it variable. So here's what we've got. Instead of the original problem that we had, we want to randomize the units sold and randomize the sale price, because we don't really know for sure what either of those will be. The data table from Chapter 2 helped, but this is a different approach. So we want you to model the units sold as a normal distribution with a mean of 12,500 and a standard deviation of 2,000. And model the price as a uniform random variable between $25 and $30. Again, I'm not going to tell you how to do it. You should be able to figure that out. This part will not be random. These will simply be calculations based on those random inputs. I will quickly show you the solution, but not the or what the solution would look like when it's completed. There we go. But not the formulas. The formulas, this is your problem to work on. It's not the assignment. This is a problem to work on as we go through. Eventually, I'll show a complete solution. But based on what we did in the last two classes, you should be able to get this part done yourself at this point. So again, the information is here on what changes we made. The cost, the same cost we had in Chapter 2, that hasn't changed at all. The profitability analysis, again, just for now, try to get up to a one trial simulation model. Go ahead and give it a shot if you haven't done it yet. They're back! Okay, they're back. Hopefully you had good luck with that problem. Now, the truly new example. I'll let you read it. Leave it up here for a few seconds. These PowerPoint slides are also on Schoology, so you can pull it off and read it there. Okay, if that wasn't enough time, pause it and read it some more. What makes this one different from the other problems we've seen is the single trial model actually is not just one set of formulas. I wouldn't necessarily expect you to figure this out completely on your own, but here's the start of what it looks like. There's not a lot of inputs. Here's the distribution of arrivals that's mentioned. So there's a 30% chance of no arrivals, 30% chance of 1, 20% chance of 2, 10% chance of 3, and on. So that's reflected in the spreadsheet. I've already put that in here as a discrete distribution. So you could make this light green as an input. The other input is that we actually start the problem as a single dock. This is the charge if there's any ships that have to sit overnight because they can only unload one ship per day. And the model actually has to start with a certain number of ships. So this isn't a single model. A single trial of this is actually, an entire year. It's 365 days. That's a one trial model. I'll show you part of the solution so you kind of know where this is going. We haven't talked about how to do multiple trials yet. That's coming. But this is a completed single trial model all the way over to column M. So if you have only one dock and you model an entire year, it gets pretty expensive. Got 2 docks. It's not so bad. So look at how do we actually build this model. But we're going to start here and take our time building the model. So how do we do this? Well, we start with whatever the model says for the beginning ships. Now the only real random part is how many ships come the next day. That is going to come off of this distribution. Remember how we do a randomization from a known discrete distribution. It's a VLOOKUP for random probability. We're going to look in this table. We want to return the arrivals. That's the 1, 2, 3rd column. And we talked about this earlier on. This is one of the few places where I actually use an approximate match on a VLOOKUP. So in our first randomly generated day, we get that. So how many ships were waiting on day 1? Well, that's the number of ships who came the previous day, or were left the previous day. How many ships get served? Well, just 2 docks. 2 ships to be served per day. How many ships are left? Well, in this case, there were 2 ships that arrived, or were there 4 ships that arrived, 2 ships waiting, 2 ships served, there's 4 left. Well, how do I get that? I could say it's how many were waiting plus how many came minus how many were served. And it looks like that's going to work. But will it always work? What if beginning ships was 0? I can't have negative ships left. So I really have to say this is max of that calculation, or 0. You might want to call this capacity instead of ships served, but I left it ships served for now. And this charge, at the end of the day, this charge is whatever's left times whatever the charge is for having something left. I don't worry about the charge here because this is considered the previous year. That's why it's day 0. This is starting the first day of the year. I'd already paid for those ships last year. These ships, sorry, last year. And this is what I'm going to end up paying. What's nice about this is if I lock my references carefully, I should be able to just copy this down for all 365 days. So I've still got a lot of simulation going on. And now, the big questions were, what were the total charges? And what was the maximum number of ships that were waiting at the end of the day? Just to see how good or bad it is. Well, the total is the sum of column J. And the max is max of column G. Sorry, I. That was silly. It's how many left at the end of the day. So these were the key outputs that I wanted. Yellow, I don't like yellow. Make them blue. So all of that is a single trial. I just wanted to show you one like this. We haven't had an example this way where a single trial actually involves lots of simulations. There's 365 days simulated for a single trial of a year. We haven't done the multiple trials yet, which is what we're going to be working on today. So see if you can catch up what I did. You can go back up the video if you need to, but see if you can get that problem working. Then we're going to go on to the very next video. You can go ahead and stop this one.